Welcome to Get Your FRQ On. This question is from 2019. It's question 1, and it is calculator active. In the question stem, we have fish entering and leaving a lake. We have a function e of t that describes the rate at which fish enter the lake, and another function L of t that describes the rate at which fish leave the lake. In part A of this question, we are asked to determine the number of fish that enter the lake from t equals 0 to t equals 5 to the nearest whole number. The number of fish that enter the lake from t equals 0 to t equals 5 can be modeled and found by evaluating the definite integral from 0 to 5 of e of t dt. And since this is a calculator active question, that is exactly what we are going to do. E of t is not exactly the type of function you want to be differentiating or integrating by hand. Using our calculator, the integral from 0 to 5 of e of t dt is the integral from 0 to 5 of 20 plus 15 sine of pi t over 6 dt, and that turns out to be 153 fish. So taking this answer, we find that there are 153 fish that enter the lake between midnight and 5 a.m. In part B of this question, we are asked to find the average number of fish that leave the lake per hour for t between 0 and 5 hours. The average number of fish that leave the lake from t equals 0 to t equals 5 can be found by evaluating the definite integral 1 over 5 minus 0 of the integral from 0 to 5 of L of t dt. And since this is a calculator active question, we're going to use our calculator. 1 over 5 minus 0 times the integral from 0 to 5 of L of t dt is going to be 1/5 of the integral from 0 to 5 of 4 plus 2 to the 1/10 t squared dt, which turns out to be 6.059. So the average number of fish that leave the lake per hour from midnight to 5 a.m. is 6.059 fish per hour. In part C of this question, we are asked at what time t between 0 and 8 is the number of fish at a maximum, and to provide a justification for our answer. The number of fish in the tank will be at a maximum when the difference between E of t and L of t is equal to 0, or at an endpoint. That is either t equals 0 or t equals 8. We'll just have to figure out which one of those it is. And since this is a calculator active question, we will use our calculator to solve this problem. So using our calculator to figure out when E of t minus L of t equals 0, we discover that this will happen when t is equal to 6.204. So in order to determine the number of fish in the lake at t equals 0, t equals 8, or t equals 6.204, we're going to have to set up an integral. So the number of fish at time t equals 0 is the integral from 0 to 0 of e of x minus L of x dx, which is just going to be 0. F of 6.204 is going to be the integral from 0 to 6.204 of e of x minus L of x dx, which turns out to be 135 fish. And f of 8 is the integral from 0 to 8 of e of x minus L of x dx, which turns out to be 81. From these calculations, we can conclude that the number of fish in the lake is maximum at t equals 6.204. In part D of the question, we are asked if the rate of change in the number of fish in the lake is increasing or decreasing at t equals 5, and to provide an explanation. So the rate of change in the number of fish at t equals 5 hours can be found by evaluating both E prime of 5 and L prime of 5. And since this is a calculator active question, we'll calculate those using our calculator. Using our calculator, E prime of 5 is negative 6.802, and L prime of 5 is 3.921. And since E prime of 5 is less than L prime of 5, the number of fish in the lake is decreasing at t equals 5. If you like my videos, make sure you like them on YouTube and subscribe to my channel for more. You can also follow me on X at x.com/getyourfrq on.